All right, we're all set. So today I'm going to show how to solve, if it'll let me right, one-step equations. All right, so we've covered before how to use each of the order of operations in each operation in said order. And we've also covered since then how to write expressions and substitute values in for variables to evaluate an expression. Today we're going to actually look at what happens if we have an equation and we need to solve it for a specific variable. So in a one-step equation, there is always one variable we need. And as the title suggests, there is one step, specifically an algebraic step that we need to take in order to solve our equation. So each of the four operations we'll need to do today are listed as such. We will have addition. We will have subtraction. Multiplication. And finally, division. The important thing to remember here is that we not only need to know how to use each of these operations, but we need to be able to identify what their inverse operation would be. So we need to know inverse operations. This is going to be the key part about solving these equations. So real quick, just to show, it'd be easier to show the inverse operation for each one. So we have that before we actually get into any equations here. So the inverse operation of addition is subtraction. In more layman speak, this would be, I would consider adding to be the opposite of subtracting and subtracting to be the opposite of adding. Inverse operations are pretty commonly known as just what is the opposite operation we need to do, but mathematically we want to be precise with our use of vocabulary. So I would say subtraction is the inverse operation of addition. Very similar to this, though, the inverse operation of subtraction would then have to be addition. A very similar case with multiplying and dividing as well. The inverse of multiplication is to divide. And the inverse of division will be multiplication. What we're going to look at in this lesson are examples of each one, mainly focusing on notation and how to keep your equations organized. So the first example we're going to look at is x plus 2 equals 4. So right away, we see our variable is x. That's what we need to solve for, right? Solve for variable. We also see what's happening with our variable. It is x plus 2. So this equation has our variable, but it's being added to. So here's where our knowledge of operations, inverse operation comes into play. Hey, what's up?
Face mask.
I ordered 2 Gators.
Okay, the Gators aren't in yet.
All right, thank you.
No worries.
So once we've identified what operation we have, we can then look at which operation we need to perform. So x plus 2, the operation present is addition, so we need to perform the inverse operation, which is subtraction. We always want to use the inverse operation with the same numbers that they have here, as that will help us. You'll see in just a minute what happens after that. One thing to note is that every operation we perform in our equation has to maintain balance in the equation itself. Our equal sign is going to act as sort of a mirror. What happens on one side of the equation also should happen on the other side. So if I subtract on one side of the equation, I should be subtracting on the other side of the equation as well. What happens here is we can then simplify each expression on each side of the equal sign. So x plus 2 minus 2, 2 minus 2, those are like terms. 2 minus 2 will go to 0, effectively canceling these terms out. You'll hear that phrase quite often. If you successfully perform an inverse operation, then you will be able to cancel out terms. So all that's left on the left side of the equation is x, and on the right side I have 4 minus 2, which simplifies to 2. So this equation is x equals 2. We'll also now take a look at an example where we have to use the opposite inverse operation. So if I have instead x minus 2 equals 4, again, we want to remember our equal sign. It's like a mirror. What happens on one side of it should happen on both. The inverse operation of subtraction is addition. So I should add 2 to both sides of the equation, because then we get to this step where we can actually simplify our expression. X minus 2 plus 2, negative 2 plus 2 goes to 0, which will effectively cancel these two terms out. All that will be left over on the left side of the equation is x, and on the right I have 4 plus 2, which is 6. As you can see, as long as we choose the correct first step with our algebraic step, these are able to be solved in one step, hence the name one-step equations. Next, we're going to look at the final two examples, one for multiplication and one for division. This is where the notation becomes a lot more important and a bit trickier to keep consistent. So right here, if I have 2x equals 4, this notation right here, 2x, the implication is that this is being multiplied, 2 times x. There is a juxtaposition where 2 is directly next to x with no space in the middle. This is multiplication. We don't always see it written, but this is as if I had 2 times x. Now, for our actual step, the inverse operation of multiplication is division, so we are going to divide. With division, I always use a fraction notation. It provides more clarity with what is actually being divided, and will be very useful later on to stay consistent with this notation. But the same principle applies. 2 times x divided by 2. I can divide my coefficient since they're part of the same term. 2 divided by 2 is 1, so effectively this simplifies to 1x. And that's a term that we don't need to write fully. So I could write 1x, but it is technically a little bit redundant, because x is the exact same thing as if I wrote 1x. It's notation we don't write. Same as with the exponents. I don't really write anything as having a 1 exponent, but unless otherwise written, you would assume it is 1. Same with the coefficient. 1x is just x. And on the other side of the equal sign, 4 divided by 2 will simplify to 2. So one well-chosen algebraic step will solve this equation. Now let's also look at what happens if I have division instead. Same thing, equal sign is a mirror, and I'm using fraction notation for full clarity on what is actually being divided. This is how most equations will be presented in this class and future math classes. So we can identify that this is division. Right. 1 second. All right, and continuing, we can see the inverse operation of multiplication of division is multiplication, and now it just comes to the point of writing it. This is more one of the more tricky steps to write clearly. Clearly, I know I need to multiply. It's just a matter of where to write it. So I can write it as times 2 written down below. Let me write it better, 2. But sometimes this can get confusing if you have an equation that's a bit more involved. So what I like to do in these is instead write my multiplication as part of the original equation. It becomes a bit more clear what we're actually multiplying and where. So right here, this is a similar position as the original problem on the left, 2 times x divided by 2. We would multiply this into the numerator, turning this into 2x. And haven't done anything over here yet. And then it's the exact same as before. So the 2 divided by 2 would cancel to the coefficient into 1x. This would just leave x on the left side of the equation, and 4 times 2 is 8. So when you are computing these on your own, you can notice in the middle step I have wrote this all in red. That's just to show what's actually happening in this step, but it is still one step. The only step I'm taking is multiplying by 2. The rest of it can be assumed to be part of this one step. But this is a quick look on how to solve each of these types of equations. From here on, you'll just gain practice in each one of them. And next, we will look at what to do when we have variables on both sides of the equation, or even just equations that take multiple steps to solve. But this is it for solving one-step equations. Thank you for listening in.